Did you know that our sun releases a continuous outflow of charged particles known as the solar wind, reaching speeds of up to 3 million kilometers per hour? But what if I told you that's not the whole story? This is just one example of the phenomenon we call stellar winds. So, what are stellar winds? Picture a cosmic breeze, an energetic stream of charged particles or plasma released by a star. These winds are not exclusive to our sun, but are a common feature of all stars, each producing them to varying degrees. These stellar winds play a significant role in the life cycle of stars and have a profound impact on the universe as we know it. Imagine for a moment a star like our Sun in the prime of its life. It's continuously emitting particles, creating a stellar wind that shapes the surrounding space. Over time, this wind can carry away a significant portion of the star's mass, influencing its evolution and eventually its demise. But stellar winds don't just affect the stars themselves, they also have a profound influence on the surrounding cosmos. They can strip planets of their atmospheres, create dazzling auroras, and even shape the stunning nebulae we see in our telescopes. Perhaps most intriguingly, stellar winds carry energy and matter into the vastness of space, influencing the process of star formation. Without stellar winds, the cosmos would look very different indeed. Stellar winds also play a role on a grander scale. They contribute to the balance of pressure within galaxies and are key players in the cosmic cycle of matter, participating in the birth and death of stars. So, as you can see, stellar winds are not just a curiosity, they are a fundamental part of our cosmic environment, shaping the universe in ways we are only beginning to understand. Now that we've set the stage, let's dive into the top 10 surprising facts about these fascinating cosmic phenomena. Starting with fact number 10, the speed of stellar winds can reach up to a whopping 800 kilometers per second. Now, let's put that into perspective. That's over 2 million kilometers per hour. Imagine, if you could travel at this speed, you could circle the Earth in just over a second. But what influences this remarkable speed? Three main factors come into play here: the star's size, its temperature, and its magnetic field. The larger the star, the more significant its gravitational pull, and thus the faster the stellar winds it releases. Similarly, a hotter star has more energetic particles, which means faster winds. Lastly, the star's magnetic field can also impact the wind speed. These invisible magnetic lines can guide and accelerate the charged particles, thereby influencing the speed of the stellar winds. Remember, though, that these factors aren't acting in isolation. There's a complex interplay between them. For example, a larger star may also have a stronger magnetic field and be hotter, all of which can add up to create some seriously speedy stellar winds. So next time you're out stargazing, remember that those peaceful twinkling stars are actually releasing incredibly fast winds into space. Fact number 9. Stellar winds play a crucial role in star formation. Now you might be asking yourself, how do these winds, these streams of charged particles, contribute to the creation of new stars? Well, imagine the cosmos as an immense sea teeming with clouds of gas and dust. These are the building blocks of stars. But for a star to be born, these materials must be gathered together, condensed into a dense core, and that's where stellar winds come in. You see, stars, especially young hot ones, emit these powerful winds. As these winds rush outwards, they push against the surrounding gas and dust. This action, this celestial nudge, can cause the materials to compress, to clump together. Over time, these dense clumps grow, their gravity attracting more and more matter. Eventually, they become dense and hot enough for nuclear fusion to ignite, giving birth to a new star. So, in a way, stars, through their stellar winds, are the architects of their own kind. They shape their surroundings, they gather the materials, and they lay the groundwork for the birth of future stars. But stellar winds do more than just build stars. They also help to mix the elements within galaxies, spreading around the heavy elements produced in stars. They shape the intricate, beautiful nebulae we see with our telescopes. In essence, they help to drive the evolution of the universe itself. Without stellar winds, the universe would be a much less dynamic place. Fact number 8. Stellar winds can strip away planetary atmospheres. Imagine a world constantly battered by a barrage of charged particles. This is the reality for planets that find themselves in the path of stellar winds. These winds, streams of plasma expelled from the outer atmosphere of a star, are incredibly powerful. They carry with them the ability to erode and even strip away the protective atmosphere of a planet. This atmospheric loss is a critical factor in determining a planet's habitability. Without a protective shield of atmosphere, a planet's surface is exposed to harmful solar radiation, potentially rendering it uninhabitable. But how does this erosion occur? Well, the stellar wind's high-energy particles collide with atmospheric molecules. This collision provides the molecules with enough energy to escape the planet's gravitational pull and be swept away into space. Over time, this process, known as atmospheric escape, can lead to the complete loss of a planet's atmosphere. Let's take our own solar system as an example. Mars, once a world with a thick atmosphere and liquid water, today stands as a barren, desert-like planet. Scientists believe that the solar wind played a significant role in Mars's transformation by stripping away its atmosphere. If Earth were closer to the Sun, its atmosphere could be stripped away by the solar wind. Such is the power and influence of stellar winds in shaping the atmospheres of planets and potentially the course of life itself. Fact number 7. Stellar winds are responsible for shaping nebulae. Isn't it fascinating that the celestial bodies we marvel at owe their existence to forces beyond our earthly comprehension? Imagine a star nearing the end of its life. As its energy reserves dwindle, it releases an extraordinary outpouring of charged particles. This is what we call a stellar wind. These stellar winds are more than just gusts in the cosmic ocean. They're architects, sculptors of the cosmos. They push and pull at the surrounding gas and dust, molding it into gorgeous, intricate patterns. Picture a nebula, a vast expanse of space filled with gas and dust, seemingly shapeless and chaotic. Then enters the stellar wind, a forceful gust blowing through the cosmic veil. It sweeps up the gas and dust in its path, pushing it outward, corralling it into clusters, etching out shapes and patterns. Over thousands, even millions of years, these patterns solidify, creating the nebulae we observe through our telescopes. The nebulae, with their stunning array of colors and shapes, are a testament to the power of stellar winds. They are the remnants of dead or dying stars, shaped and formed by the very winds these stars expelled in their last breaths. So, the next time you gaze at an image of a nebula, remember this: you're not just looking at a cloud of gas and dust. You're looking at a cosmic sculpture, a work of art created by the powerful gusts of stellar winds. So when you see a nebula, you're actually looking at the effects of stellar winds. Fact number 6. Stellar winds contribute to cosmic rays. Now this is where things get truly fascinating. These stellar winds, the streams of charged particles released by stars, play a significant role in creating cosmic rays. Cosmic rays are extremely high-energy radiation, mainly originating from outside the solar system. They're not rays in the way we think of light rays or X-rays, but rather individual particles, protons or atomic nuclei, accelerated to near the speed of light. How does this happen, you might ask? Well, it all starts with a star. Stars, like our Sun, constantly emit stellar winds. These winds are composed of charged particles that move at incredible speeds, often millions of miles per hour. When these particles reach the shock fronts of these winds, they bounce around, gaining energy with each collision. This process, known as Fermi acceleration, can boost these particles to speeds close to that of light, transforming them into cosmic rays. These cosmic rays, filled with energy from their stellar wind-driven journey, then zip through the cosmos. They bombard anything in their path, from distant planets to astronauts in space. So, in a sense, we owe the very existence of cosmic rays to the stellar winds. By accelerating particles to high energies, they create these cosmic rays, filling our universe with high-energy particles. Stellar winds not only shape the universe, but they also fill it with high-energy particles. Fact number 5. Stellar winds can affect space weather. But how, you may wonder? Well, let's take a step back and consider the Sun, our very own star. The Sun constantly emits a stream of charged particles known as the solar wind. This wind, a type of stellar wind, rushes out into space at speeds of up to 1,000,000 miles per hour. Now imagine these winds interacting with the Earth's magnetic field. This interaction can lead to what we call geomagnetic storms. These storms are not just beautiful northern and southern lights or auroras dancing in our night sky. They can have much more serious consequences. For instance, they can cause significant disturbances in our satellites' functioning, which we rely on for everything from GPS navigation to weather forecasts. But it doesn't stop there. These geomagnetic storms can even impact power grids here on Earth, leading to large-scale blackouts. So when we talk about space weather, we're not just talking about conditions out there in the cosmos. We're also talking about events that can have direct, tangible effects on our everyday lives here on Earth. It's amazing to think that stellar winds, these seemingly distant and abstract phenomena, can have such a profound impact on our world. So yes, even space has its own weather systems thanks to stellar winds. Fact number 4. The most powerful stellar winds come from supernovae. These celestial powerhouses are not your average stars. They are the dramatic finale of a star's life cycle, ending in a cataclysmic explosion that can outshine entire galaxies. The winds they produce are in a league of their own, both in terms of energy and impact. When a star goes supernova, the energy it releases is so vast that it can be seen across the universe. This energy drives winds of charged particles away from the star at nearly the speed of light. These are the supernova winds, a force so potent that they can shape the very fabric of the cosmos. These winds are more than just cosmic gusts. They are shapers and creators, carving out cavities in the surrounding interstellar medium and triggering the formation of new stars. They are also destroyers, sweeping away everything in their path and altering the chemical composition of their surrounding space. The power of these winds is truly staggering. To put it in perspective, the energy released by a single supernova wind is so immense that it can match the sun's total energy output across its 10 billion years lifespan. So, next time you gaze up at the night sky, remember the silent powerhouses that are supernova and the winds they produce that shape our universe. The winds from a single supernova can release as much energy as the sun will in its entire lifetime. Fact number 3. Stellar winds can signal the death of a star. Stars are like celestial beings with their own life stages. They're born, they mature, and eventually they die. And just like the changing seasons of life on Earth, stars too exhibit certain signs when they're nearing their end. One of the most striking of these signs is an increase in stellar wind activity. Let's delve into the concept of stellar winds for a bit. These are streams of charged particles that stars, like our own sun, constantly release into space. Normally, these winds are relatively stable, but as a star grows old and its fuel starts to deplete, things begin to change. The star expands into a red giant and its outer layers become more unstable. This instability results in stronger and more frequent stellar winds. In other words, the star begins to lose its matter into space at a much faster rate. And this, my friends, is a sign of a star nearing its death. These increased stellar winds, carrying away the star's matter, continue until the star has lost so much of its mass that it can no longer sustain nuclear fusion. At this point, the star collapses under its own gravity, leading to a spectacular supernova explosion or forming a white dwarf, neutron star, or even a black hole, depending on its initial mass. When a star starts to blow harder, it's essentially blowing its last breath. Fact number 2. There's still so much we don't know about stellar winds. Isn't it intriguing? Despite the leaps and bounds in our knowledge of the cosmos, stellar winds remain a tantalizing enigma. These cosmic gusts, a stream of charged particles released by stars, are a fundamental aspect of our universe. Yet there's so much we're still trying to unravel. One of the biggest questions we have is, how are they generated? We know that they're associated with the movement of plasma in the star's outer layer, but the exact mechanism is still a mystery. Scientists have proposed various theories, from magnetic fields to thermal pressure, but none have been definitively proven. Then there's the question of their speed. Stellar winds can vary enormously, from a gentle breeze to a swift hurricane. Some stars, like our Sun, have winds that travel at a leisurely 1 million miles per hour. But others, like young, hot, massive stars, can have winds that reach an astonishing 6 million miles per hour. What causes this huge variation? Again, we're still not sure. And let's not forget the puzzle of how these winds affect the evolution of stars and the formation of new ones. They play a crucial role, but exactly how and why is still a subject of ongoing research. Stellar winds remain one of the great mysteries of astrophysics. But with every mystery comes the promise of discovery, and that makes the quest all the more exciting. And finally, fact number one: stellar winds may have played a role in the development of life on Earth. This statement might sound like a line from a science fiction novel, but it's grounded in serious scientific theories. Stellar winds, these streams of charged particles that stars, including our own sun, constantly release into space, have been doing so for billions of years. And it's these winds that might have brought the necessary elements for life to our very own planet. Imagine stellar winds as cosmic delivery services, carrying elements like carbon, nitrogen, and oxygen across the vast distances of space. These are the very elements that form the backbone of life as we know it. Theories suggest that these elements may have been implanted into the Earth's early atmosphere by these winds, setting the stage for life to take root. But the role of stellar winds doesn't stop there. They also act as a protective shield, deflecting harmful cosmic rays that could potentially damage life on Earth. These cosmic rays are high-energy particles from outer space, and exposure to them can have detrimental effects on living organisms. So, these stellar winds, while invisible and intangible to us, could be the unsung heroes of our existence, playing a vital role in both the creation and preservation of life on Earth. So, next time you enjoy a breath of fresh air, remember to thank the stellar winds. We've journeyed through the universe, exploring the surprising and powerful world of stellar winds. These invisible streams of charged particles ejected by stars have an impact that's both far-reaching and profound. Let's take a few moments to recap this cosmic journey. We've discovered the astonishing speeds at which stellar winds travel, often reaching several million miles per hour. These winds, while invisible to the naked eye, play an essential role in the formation of stars. They compress interstellar gas and dust, creating dense regions that eventually collapse under their own weight, giving birth to new stars. We've also explored how stellar winds shape nebulae, those beautiful cloud-like structures we see in deep space images. These winds sculpt the nebulae, creating intricate patterns and breathtaking cosmic landscapes. In addition, we've delved into the significant impact of stellar winds on planetary atmospheres. They can strip them away entirely, creating barren, inhospitable worlds. But there's a silver lining. Stellar winds also contribute to the creation of auroras, those mesmerizing light shows in the skies of Earth and other planets. Moreover, we've discussed the role of stellar winds in cosmic rays. These high-energy particles, some of which reach Earth, originate from the sun's stellar winds and other cosmic phenomena. We've even touched upon the power of supernova winds, which are stellar winds on steroids, so to speak. They are the driving force behind some of the most explosive events in the cosmos. Lastly, we've pondered the possible role of stellar winds in the development of life on Earth. Some theories suggest they may have delivered the necessary ingredients for life to our planet. So the next time you gaze up at the stars, remember the unseen winds that shape the cosmos, and keep wondering about the mysteries of the universe. As we draw our cosmic exploration to a close, let's pause and reflect on the profound implications of stellar winds. Through their silent, ceaseless whispering, these winds tell a tale of creation and destruction, of life and death. They shape the physical universe, sculpting nebulae and influencing the birth of stars. They impact planetary atmospheres, sometimes stripping them away, but also illuminating the night sky with awe-inspiring auroras. Stellar winds even play a role in the high-energy cosmic rays that reach our planet and may have contributed to the emergence of life on Earth. These invisible currents coursing through the vast expanse of space are a testament to the dynamic and interconnected nature of the cosmos. They serve as a reminder that even the seemingly tranquil stars in our night sky are active participants in the cosmic drama. The next time you gaze up at the stars, remember the unseen winds that shape the cosmos. Imagine the stellar winds whispering their tales of cosmic creation and destruction. And keep wondering, keep questioning, keep exploring the mysteries of the universe. If you've learned something new from this video, please give it a like and share your thoughts in the comments section. Don't forget to subscribe and hit the bell icon for more content like this. And of course, feel free to share this cosmic journey with your friends and family. After all, the universe is a vast place and there's plenty of room for everyone to explore. Until next time, keep looking up.